Welcome back. Now we're going to get into how we connect bare metal hosts to the ACI fabric. And again, where are we going to connect bare metal hosts? Are we going to connect them to a spine switch? Nah, right? These guys go onto leaf switches, and we still have a lot of bare metal hosts out there. So when I say bare metal, I'm really talking about anything that does not have a hypervisor, right? From a bare metal host perspective, most of the time this is going to be our physical servers that we have sitting out there in the data center that, again, aren't running ACI, they're not running any sort of Hyper-V or anything else. These are going to be typically running some legacy apps, because while a lot of data centers are moving to fully virtualized environments, that concept hasn't been really realized fully within the enterprise environment. So we still have a lot of, typically it's legacy applications that just don't have the ability to be virtualized. So that is causing us to basically hold off on the full virtualization of our data centers. So this is still very prevalent, and we are still going to have bare metal host or physical servers connecting to the ACI leaf switches. When we do our demo for these, what I think I'm going to end up doing is using switches. So basically, I think we'll use 7Ks to simulate bare metal hosts hanging off the fabric. We'll find that, you know, these servers could be running just Microsoft Windows. They could be tagging traffic. They could not be tagging traffic. We could be using native VLANs. We're going to see there's a couple different options within the ACI config for bare metal host connectivity to get them running. All right. So let me zoom in here. What we'll find is these guys are going to be part of a physical domain. So remember our 4 domain types? If you know them, go ahead and say them in your head. So we had 1, 2, 3, and 4. The first one was going to be our external layer 2. Then we had our external layer 3. Then we had our VMM, and then we had physical. So the bare metal host config is going to be a physical config, right? Because we're physically connecting to there, and it's bare metal. So it doesn't really fall into any of these other 3 categories, layer 2, I guess it could, but we're not using it with the same semantics in terms of layer 2. But it doesn't really fall into any of these other 3. So really we're looking at a physical config here. Now, think about this. We're going to be taking, say, a server, and we're going to be connecting this server up to, you know, one of our leaves. We could say, you know, this guy's going to be connected up to leaf 1. Okay. If we're connecting it up like this, this might be node ID, you know, 101. So I'll put another little block out here. And if we're going to follow our example up here, maybe this is port 12. Okay. So there's a couple things we're going to have to do as we go through this config. And if you remember kind of the steps that we have to take, remember we always have to provision the physical fabric first. So we're going to have, you know, our switch profile, which I'm just going to call SWP. We're going to have our interface profile, which I'll just call INT-P. We're going to have our interface policy groups. We're going to have our AAEP. We're going to have our domain. And what was the thing at the very end? Our VLAN pool, right? So we still have to have a VLAN pool. And this is, again, going to be used for some internal mapping and classification into an EPG. So as you can see here, I am basically saying I'm going to be taking everything off VLAN 20. So my encapsulation off of this specific port is going to be within VLAN 20. This VLAN has to be within this VLAN pool that we create up here. So again, we still have to do all this work. Don't forget that you have to work and create all of these in order to provision a VLAN basically off of a switch port, right? So as long as that VLAN that you're bringing off of that link is within this VLAN pool, you're cool. You're cool. Now, we could also go in and deploy this either on demand, meaning as soon as the port is brought up and we start seeing traffic coming in, is when we could push this configuration down to that leaf switch, or you could do it immediately. I'll tell you right now, I typically do it immediate just to make sure that everything actually gets provisioned down at the leaf switch, because sometimes you may want to provision it before that server actually shows up. And I'm one of those guys who personally likes to go in and be able to verify through the CLI on that leaf switch that that everything's provisioned down there in terms of VLANs, and just making sure that the VRF, the bridge domain, and everything is being seen down at that particular leaf node. So this mode here is a little bit tricky. All right, the mode is a little bit tricky. But what we're going to be doing is specifying whether traffic is going to come in tagged, which would be ID'd by this trunk declaration. If it's going to be an access and we're expecting 802.1p bits, this is basically the equivalent of a native VLAN declaration. So if we choose access 802.1p and then say VLAN 20, basically we're expecting untagged traffic coming in on this port to get mapped to, in this case, VLAN 20, and then within whatever EPG we're creating this within. Because this field that you see here is basically the static path binding field, and we do that under a particular EPG. Okay, we're doing that under a particular EPG. So let me clean this up a little bit, and let's go through each of these scenarios so that we're crystal clear. So this box right here was brought forth by us going under our tenant, and I'm doing this from memory, so I hope I'm right. We went under our specific tenant, we went under our application profile, and then we went under our EPG. Okay, and under our EPG we went to static path binding. So basically, we're mapping something into this endpoint group based on a static path binding. And in this particular static path binding, we're saying, hey, on node 101, so let's create node 101 here. This is our leaf switch that is node 101. We're saying off port 12, so if this were port 12, in this specific example, we're expecting trunked or tagged traffic on VLAN 20. So we would be expecting, I'm just going to call this a host, we would be expecting with this configuration a frame to come in tagged with VLAN 20 into that leaf. So anything that met that requirement, anything coming in tagged on VLAN 20 is going to be mapped, and let me draw a different colored line here, is going to be mapped into this particular EPG. And that was not a different color, Jason. Okay, so everything coming in tagged and VLAN 20 is getting mapped into that endpoint group. We have a couple other options here, and let me erase a couple things off of this. Boom. All right, the next option would be if we came in and said access 802.1p. Okay, with access 802.1p, we're basically saying this is still a trunk, right? So this link is still a trunk, but we're expecting something to come in. I'm just going to have brackets here because this is untagged. Actually, let's just put a U in there. So we're expecting stuff to come in untagged in this port, okay? And we're going to be mapping it to this particular EPG. Okay, so untagged traffic would be mapped into that EPG. The benefit of this untagged configuration, guys and gals, is that we could come in on this same port later and expect tagged traffic. Okay, so I could be using this in one static path binding, expecting stuff to come in untagged, and then I could use it with another static path binding, maybe to a different EPG, expecting tagged traffic. So I put a little note in the slides, which you guys will be able to download, but this will let other tagged EPGs exist on the same interface. This is different than if we were to come in and declare just access port untagged. Okay, if we were to come in and say access port untagged, all that we'd be doing is expecting untagged traffic to come in that port. We would map this untagged traffic to our internal VLAN 20 and to this EPG. Okay? The biggie with this access untagged declaration is that you can never use this port for anything else. Okay? So if I ever wanted to accept also, tagged traffic from this host, I would not be able to do so. Okay? Because I had said that this is an access port. All right. So if you do access untagged, you can never accept tag traffic on the port to map to another EPG. If you say access 802.1p, you can accept untagged traffic and then come back later and accept tag traffic on the same link. All right, that's the big difference between those guys. Now again, there is a pretty big process flow. We kind of already hit on that, but as you go through to configure the bare metal host, and I've kind of, again, I threw this in there because I tried to do my version of mind maps so that you guys could have a copy of these. So this is kind of what I had going is we would come in and for our bare metal host connectivity, we'd create a static VLAN pool. You guys can kind of follow along with me here. Create our static VLAN pool, then we'd create our physical domain. We would reference the VLAN pool within that physical domain and then reference the AAEP or the Attachable Access Entity Profile. If you haven't created the AAEP, you're going to need to do so. I didn't throw that in here, but I did put in brackets there, if created. And then you're going to go into your tenant. So after you provisioned the physical fabric, I guess the other stuff I left out of here is the switch profile, the interface profile, and the interface policy groups. I'm kind of assuming that you've already got that stuff done, but if you haven't, those are going to be the other things you need to do, and then you're of course going to map that interface policy group to that AAP. But once that physical stuff is done, we'll go under our tenant, static path binding, specify the port type, the reference ports, the NCAP VLAN, the deployment mode, and then whether it's going to be tagged, untagged, or 802.1p. So with this port type, I was speaking access ports, but we're also going to need to make sure that we have the correct switch ID referenced within that config. So what switch is this hanging off of, then what port is it hanging off of? And then of course we're going to have to do our contracts, filters, and then provided consumer relationships in order to actually pass traffic to and from that node that we just connected up to the fabric. So while again it may seem like a ton of steps, right? Because what did we have to do when we connect bare metal hosts with NXOS? We would go in and we'd say, you know, interface Ethernet 1.1, switch, mode, you know, access or trunk, you know, switch, access, VLAN 10, et cetera, et cetera. But we're getting so much more with ACI, right? The config, sure. It was a lot easier to go into NXOS or even iOS and blast out a config that's going to allow us to connect up a server. But now we get all the policy that goes around it, right? We can limit what goes to and from that bare metal host. We can give it relationships. We can do service chaining. So the policy aspect of this is the big part. Okay, it's not just connecting up a host to a switch anymore. It's connecting up a host to a policy-driven infrastructure, okay, that we can, again, write reusable objects, we can access through the API. And again, that brings up a good point. This may be very lengthy to do through the APIC GUI, but once you understand these constructs, this is going to be something that you can script into a chef cookbook, and you can just run it. It's going to take you 3 seconds to connect a new host up to the network. So that's what this course is aimed to drive home, though, is what are the constructs within ACI that we have to use in order to accomplish these specific tasks.